Students, in today's video, we will see how we can use Taylor polynomial to find approximate value of function at any given random point. So here we will find approximate value of cos of 64 using Taylor polynomial. Okay, so first of all, we know Taylor series expansion of f of x about a. So which is this, f of x is equal to f of a plus f dash of a into x minus a plus f double dash of a upon 2 factorial x minus a square and so on. Let us call this as equation number 1. We know that this series expansion, the right hand side, gives us a very good approximation, or you can say approximation in the neighborhood of point a comma f of a, or approximation about x is equal to a. So whenever our input is very close to this point a, then this series will give us a very good approximation, or a good approximation for that value of f at that point. Let's say any point which is close to a, let's say b. If b is sufficiently close to a, by using this expansion you can find f of b, so value of f at b. Now how close? So that point has to be, for example, if let us call this that let us take this distance x minus a as h. Okay, so let x minus a, so this h has to be between -1 and +1. Okay, such that -1 is less than h is less than 1. You'll see why this h is between -1 and +1. If it is there, this will give us a good approximation, that is mod of h is less than 1. So now let us put this in equation number 1. So we'll get f of a plus h is equal to f of a plus f dash of a into h plus f double dash of a upon 2 factorial h square plus f triple dash of a upon 3 factorial h cube and so on. Let us call this as equation number 2. Now you can see here, if mod of h is less than 1, as we go on increasing these terms, so powers of h are increasing, and because mod of h is less than 1, these terms will tend to 0. As power of h tends to infinity, this term will tend to 0. So after few terms, the next terms are negligible. When that will happen? Only if mod of h is less than 1. So therefore, if the point now, so here this is our b, if b is in h neighborhood of a, h neighborhood in the sense distance between b and a should be less than 1, in that case we can use this Taylor series expansion, this one, to evaluate f at point b. Alright, so using this equation now, second one, we will find this cos of 64. So for that, so let f of x as cos of x, this is our function. So we have to find f of a, so we have to decide what is a and h. Now we know that cos 60, we know what is a cos 60, right? So let us take the a as 60. So f of x as cos x, a as 60. Why we are taking a as 60? Because we know value of f at that point, right? 60 degree. You can take a as other values also that we know. For example, you can take a as 45 also. But in that case, what will happen? If you take a as 45, you need to take h as 19, so that you will reach to 64. 45 plus 90, 64, right? But h is increasing unnecessarily. What you can do? So you choose a so that h will be smallest possible, and therefore here we are choosing a as 60. See, even you can choose A as 0 degree also, but in that case H will be 64, which is very big compared to what we are getting here now. When you take A is equal to 60, therefore H will be 64 minus 60, which is 4 degree, which is equal to how much? 4 into 180, 4 into pi upon 180. We need all this in radian. So here you can see H is equal to 0.0698. Okay, so we got f of x, a and h. Now just we have to find this f of a, f dash of a, f double dash of a and put it here. So let's find this now. F of x is equal to cos x. So what is f of a? That is f of 60 cos 60, and we know that cos 60 is 0.5. Then f dash of x, which is minus sin x. What is f dash of a? Which is minus sine of 60. We know that sine 60 is root 3 by 2. So it is minus root 3 by 2, which is equal to minus 0.8660. Then f double dash of x, which is minus cos of x. Therefore f double dash at 60 is equal to minus cos of 60, which is minus 0.5. Similarly, we can find f triple dash at x, which is sin x. Therefore third derivative of f at 60 will be sin 60, which is 0.8660, and so on. You can go on doing this, but see here, because h is the 0.0698, even if you take up to h cube, it is sufficient, because in h cube only there will be 3 zeros after decimal place. So this will give you answer correct up to maybe 3 to 4 decimal places, so which is sufficient. If you go on increasing these terms, we'll get more accurate answer. Instead of 3, if you take 5, 6, 7 terms, it will give you more accurate answer. But see, for practical purpose, it is now sufficient up to even h cube also. So we will take up to this only. Now what else we need? We need value of h, okay, which is 0.0698. Then we'll need h square also. So let us take it square, which is 0.00487. Then we need h cube also, which is 0.00034. Alright, so we got all the values. Now put all these values in equation 1. So put all, in equation 2. So what you will get? F at a, which is 60, plus h 4, right? That is f of 64 is what? F of a. What is f of a? That is f of 60 plus, right, f of 60 plus h. So let's put values this now. What is f of 60? We have that 0.5 plus h into, so 0.0698, f dash at 60, which is minus 0.8660, plus what next? H square by 2. So you can see here we are increasing power of h, and even we are dividing it by higher number now, bigger number, right? Now we are dividing by 2 factorial into f double dash 60, which is minus 0.5 plus h cube, and we are dividing here by 3 factorial, which is 6 into f triple dash 60, which is 0.8660. Okay, so when we do all these calculations, it will give us 0.43838. All right, this is what our f of 64, or what was that? F is cos of 64, so which is approximately equal to 0.43838. So this is how by using Taylor polynomial we can find approximate value of function. So only thing here is you have to choose a and h properly. Generally mod of h has to be less than 1. So this is what answer we got. So this answer is approximate. If you go on increasing the terms, you get more accurate answer. Now let's compare this answer with the actual answer, and the actual answer is using calculator. So if you use calculator to calculate this, cos of 64 is 0.43837 and so on. Okay, we'll consider first 5 terms only. So look at here, we got answer correct up to almost 4 decimal places. It is exactly equal. And look at the last 5th term also. Here it is 8 and here it is 7. So we got very good approximation. So this is how using Taylor series or Taylor polynomial we can find approximate value of a function at a point. I hope you understood this. Thank you.